All right, so 5 through 8 in this video. With these first two, the easiest thing to do is going to be to just put those values in and see what happens. For number 5, we don't need to make it look like y equals mx plus b. We can just do it as it is. And so we'll go ahead and leave this equation looking like this. And from there, put our x value in and our y value in, and if it makes a true statement, then it satisfies the function. So we've got 9 times 0 minus 7 times 1 equals negative 7. 0 minus 7 equals negative 7. Negative 7 equals negative 7. So yes, that satisfies the function. For b, 9x minus 7y equals negative 7. So 9 times 0 minus 7 times 7 ninths equals negative 7. And so we would have 0 minus 49 over 9 equals negative 7. And no, negative 49 over 9 is not negative 7. So b is out. The other way to notice that b would be out is we already have a number that's paired with 0. So for a, we have 0, 1. And so for a function, it can't have more than one y value for every x value. So b loses because it can't be with 1 and negative 7 ninths at the same time. Or is that negative 7 ninths? I forgot my negative on my problem, didn't I? So let's fix that. That would make that a positive 49 over 9. Still doesn't change the fact that it's not going to work. So there we go. Moving on to C. 9x minus 7y equals negative 7. 9 times 7 minus 7 times 10 equals negative 7. We had 63 minus 70 equals negative 7. And yes, negative 7 is equal to negative 7. So C satisfies the function. And D, 9x minus 7y equals negative 7. So 9 times negative 5 minus 7 times 3 equals negative 7. So that is negative 45 minus 21 equals negative 7. This is not going to work. It's going to be negative 66 is not equal to negative 7. So D is out. That's it for number 5. We'll bounce over to number 6. So again, similarly, we're just going to test these points in the equation and see if it makes a true statement. So y equals 6x minus 2. 16 equals 6 times 3 minus 2. 16 equals 18 minus 2. And 16 equals 16. Yes, that's a true statement. So satisfies the function. For b, again, the same equation, y equals 6x minus 2. Negative 2 is equal to 6 times 0 minus 2. Negative 2 equals 0 minus 2. And we get negative 2 equals negative 2. Yep. That's a true statement, so it satisfies the function. For C, y equals 6x minus 2. We're going to have 0 equals 6 times 0 minus 2. I don't think this one's going to work. 0 equals 0 minus 2. And 0 is not equal to negative 2. So C is out. D, y equals 6x minus 2. We got 4 is equal to 6 times 1 minus 2. So 4 is equal to 6 minus 2. 4 is equal to 4. And so yes, D satisfies the function. Alrighty, moving on to 7 and 8. I'll pause here for a moment. Okay, number 7, and so it's a graph. The first thing we want to do is plot any points on the graph that we can and see if they land on the line. So 1, 0, A is not going to work. Negative 4, 2, B is not going to work. Negative 2, 2, C lands on the line. And D, negative 6, 8. Let's go ahead and set up an equation for that one. So we can see from the graph that our slope is negative 1, 2, 3 over 2. So slope is negative 3 over 2. Our y-intercept is negative 1. So we can make the equation y equals negative 3 over 2x minus 1. And now let's take our values and put them in there and see what we get. So for D, our y value is 8. Negative 3 over 2 times negative 6 minus 1. And so we're going to get 8 equals positive 18 over 2 minus 1. 8 equals 9 minus 1. 8 equals 8. So yes, D does satisfy the function. And moving on to number 8, we have 0, 9. Well, that's going to be way up there somewhere. So obviously, that's not going to land on the line. Negative 3, 0. So right here. That's not on the line. Negative 3, negative 4. Definitely lands on the line. And negative 2, 3. Not on the line. So the only one in that set that satisfies the function is C. And that's it for this video. I'll leave it here for a moment so you can pause and take notes if you need to.